In problem 4, we're asked to find the angle alpha that creates the maximum moment of F about point 0. In other words, how do we orient F so that we get the biggest torque about point 0? And that's all about creating a right angle then that maximizes this distance between O and A. And so that's just really a matter of coming in here and figuring out what this right triangle looks like, and the base of it is going to be 70 plus 150 plus another 70, and so that's 140, and that's 290 total. And then the height is going to be 25 plus the 70 on the radius plus another 70 plus another 25, so that's 50, and that's 190. Let me check that math. 25, that's 50, yep, that's correct there, and 70, that's 140 plus 150, 290, we're good. So our alpha angle here, those are the two same ones, so alpha equals, of course, arctan of opposite over adjacent, and so 190 divided by 290, arctan, oops, and you get alpha equal to 33.2 degrees is the answer for number 4. Again, you want a perpendicular distance. Point A doesn't move, but the orientation of the force does to create the maximum torque possible.